Um, Hello everyone. My name is Amanya Alan Kayumbu. I'll be taking you through a final presentation on our artificial intelligence project, which is disease prediction with machine learning. I'm going to make this video, but my other partner is also going to be making another video. Yeah, so let's commence. So the introduction. Our project has four major keywords, which are disease prediction, machine learning, and artificial intelligence. So this basically describes the different diseases that are to be predicted by the machine learning model with different metrics as shown in the data. And prediction, the machine learning model is supposed to predict different diseases based on different symptoms. Then the artificial intelligence bit of the project, the whole point is for the machine learning model to be able to predict a particular disease based on that symptoms that are fed into it by the possibly health worker. And yeah, so the problem being tackled is disease prediction of various diseases based on various symptoms. So the aim of the project is to create a machine learning model that is able to predict a disease. As we all know, some diseases have similar symptoms. So the aim is to create a model at the end of this whole project, which would be able to identify a particular disease based on particular symptoms. Yeah, so background, disease basically refers to a disorder or structure, disorder of the structure or function of the human body. Prediction is a term in relation to in our project is all about having the ability to predict and determine a particular disease in relation to the symptoms highlighted. Machine learning is a model in artificial intelligence, as we're making a machine learning model that is about to develop computer systems that can learn and adapt without external explicit instructions. Then artificial intelligence, a field of science that deals with building computers that reason and act in a way that would require human understanding. So creating a model that is able to understand that this symptom is for this particular disease and not for this is the aim of this whole project. Yeah, so simple literature of our project. Artificial intelligence has supervised and unsupervised learning models, but mostly supervised learning models are being used in this project, which are under classification, which is under regression. Yeah. Yeah, so classification problems use an algorithm to accurately assign test data into specific categories, such as separating malaria from typhoid and many others. Supervised learning algorithms can be used to classify sperm in a different folder. The weakness of this method was the many diseases that had similar symptoms that I had mentioned before, which made it hard to classify diseases. But obviously, as time goes on, that will be modified. Yeah, so the different algorithms that were used in this model are Bayes Bayes, which is a probabilistic classification algorithm based on the Bayes theorem, with strong independence functions, where a feature of one object does not affect the other. And then a decision tree classifier, the supervised learning algorithm that can be used for both classification and regression, but mostly preferred for classification, as well as random forest classifier, which is basically a large number of decision trees on various data subsets that take an average of all the decisions from the decision trees to improve the accuracy. So the methodology used for this project has particular steps. We have data collection, which involves collecting high quality and representative data on patients. Data processing, which involves cleaning and transforming that data. Model selection, which involves choosing an appropriate AI model, such as decision tree or random forest or Gaussian naive Bayes, like I mentioned before. Then model training, which involves using the pre-processed data to train the model. Model evaluation, which involves evaluating the performance of the model and separate test data sets to assess its accuracy. So we move to the dataset description. Our dataset was already split. It had training data and test data. The training data is what we use to teach our machine learning model and assess its accuracy based on the preset symptoms and diseases. So basically, we're teaching it that with this particular symptom, it's for this particular disease. The symptoms are weighed according to 1s and 0, where 1 is for that disease and 0 isn't. So yeah, that's how the data set is. And the factors we used while choosing this data set was diversity, which entails the various symptoms. Exhaustion, which shows the numerous diseases that are being studied. The size, obviously we want to teach our machine learning model in a very large data sets for it to be liable. And the explainability of that data set, which is basically, like I'd said, the different symptoms being either 1 or 0. Yeah, so we generated a heat map showing the correlation of the symptoms, showing high and low correlation. The low correlation is shown from the symptoms that have a very a lighter color than the rest. High correlation, that's where the darkest color is shown in the heat map. So this is like high correlation. Sorry, this is low correlation. This is high correlation, something of that sort. Then yeah, we managed to generate box plots, which are which show the dependence of the prognosis and the particular symptom. So these were symptoms that had high correlation chosen from the correlation heat map. Yeah, so the heat map shows different symptoms of various diseases in the dataset, showing symptoms of high and low correlation. In the dataset, there are no missing values. The cells that had null data were removed in the process of data processing and cleaning, as I mentioned. So the AI model selection, these models fall under regression models, where we use decision trees and random forest. Like I mentioned before, decision tree is basically a tree structure of decisions along with the possible outcome, in this case being the different diseases. And random forest consists of many decision trees working towards a particular outcome. AI model selection accountability. By this, we refer to basically making an AI model that is within the livelihood of the people. Basically not being able to compromise the living of the people that's within the That's the environment of the AI model. The different features of AI accountability include context, range, agent, forum, standard processes, and implications. So in a conclusion of our project, our initial project was actually supposed to be a recommender system, as you might see from my previous videos. We faced a couple of technical difficulties with the data set. We had some difficulty in trying to transform some particular data set into numerical data, which would have been easier for us to work with. And we had to use 2 different data sets, which were a little bit hectic for us. So we ended up changing projects to a disease prediction model for machine learning, which I've been describing. But the different related videos before, like I had been posting, would be still in correlation to the project because it's not really much of a difference. The terms and the different factors still lie within the project. So yeah, this is a link to our dataset that we used, which guided us on making this project. And these are the various references running from people's term papers and other websites. So yeah, that is it for my video. Thank you very much.